I think that's great. Okay, so has anybody managed to get B before we get going? Anybody got the 24 for maths for B? I'm not going to give it away if nobody gets it. We can always start the next lesson with it. But I want to give a little bit of time. Okay. All right, so then for the moment, B will remain a question, a challenge for a future lesson. You can get it though. So Tukela, the goal of this exercise, we do this at the beginning of every lesson. We try to make 24 using 4 numbers, and we can only use each number once, and we can only use the operations plus, minus, times, and divide. Ooh, Pumuzile has said 2 times 8. Has she snuck in there at the last minutes? 2 times 8 is 16. 16 plus 3 plus 3, you close, but no cigar, because you've got 22. But that was a good effort. Okay, let's properly start the lesson. So I just want to do some admin. This is the second lesson on a topic of exponents. And so at the end of the lesson, there'll be like a little fun quiz that Lebo or me or someone will post in the chat. And when you go off to do that quiz, the lesson is done. You don't have to come back. And it's just a fun quiz to see how much you're retaining from the lessons. And so we call that, it's basically, it'll be in the chat, and you need to log in. You need to use your login, I think, to access it. Okay, then in the last lesson, when we were speaking about exponents, and we were kind of stuck at this point over here. I was doing this question. My main summary of the last lesson was that if you have an exponent to a power, all it means is you repeatedly multiply the thing below it that many times. So 2 to the power of 3 is actually the same as 2 times 2 times 2. And that is also the same as 8. And so we call this thing over here, we call this exponential notation, because essentially we're using powers to express the number 8. And it's often very effective when we want to write things quickly and work with things, big numbers, quickly and efficiently. That's the one thing of doing it. But the main idea was that it's repeated multiplication. It's a quick way of writing repeated multiplication. Now, today, we're going to start to extend that idea a little bit. And so I want to start with these 3 questions. And I want you to simplify these and then write them in exponential notation. So when I say 5 to the power of 4 to the power of 10, what does that mean? And what would that be equivalent to? And so I'm actually going to call this A, B, and C. It's easier. And when you get your answer, if you could pop that in the chat. What I will say is that the first one, I will actually give you a bit of a hint. How many have I got? 1, 2, 3, 4. You don't have to write it out like I'm doing, but I want to make a point. Now, how can I simplify that? Oh, Rebetswe is making a late challenge. Rebetswe, I'll come back to that in a moment. Oh, have I written too many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, I'm good. So what will the answer be? And if you want to type it in fact, I'll do this one for you. In your calculate, or in the chat, if you want to write to the power of, we just use this symbol over here. So 5 to the power of what is the answer for A? Okay, I see some answers coming in. I'll give you a bit more time before I give you the answer for A. Okay. So when I say to you 5 to the power of 4 to the power of 10, what that means is that 5 to the power of 4, which is the thing below the power, that gets repeated 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you've got, what does 5 to the 4 mean? 5 to the 4 means 5 times 5 times 5 times 5. But what you quickly realize is that there's 10 of these, and there's 4 in each one, so it'll be 5 to the power of 40. And what we ended the last lesson with was what we realized is, instead of, we can write it out the full way, and it's an important thing to do sometimes. But if you've got two powers next to each other, a shortcut of doing it is to multiply the two powers together. And so that's one of the ways we can deal with exponents. When we have two powers next to each other, we can actually just multiply the powers together. But I wanted to show you kind of where that comes from. Otherwise, you think it's just magic. Okay, what are the answers for booleans? Okay, I see Awande's answer. I see Ori. I'll give it a little bit of time. So another thing is we really want to see students putting their answers in the chat. Even if they get it wrong, we know that students remember things better. Even if they put the wrong answer, when they see the right answer, they remember it better if they did something. Okay, so I see the answers, and you're quite right. For 1.2, the answer is going to be 10 to the power of 20. So 10 to the power of 20. And then the answer for C is going to be 6 to the power of 16. And so I just want to point this out. It's not wrong. We could have done with B. What, in the most technical way, 10 to the power of 4 to the power of 5, it actually means that. But because we know that's going to happen, eventually we notice this pattern, and it allows us then to take the shortcut where we can multiply these two together. Because remember, 10 to the 4 is just, but if I did that, I'd be writing all day. And so that's why we develop these rules. When we deal with exponents, we develop these shortcuts or these rules that we can use to make life a bit easier. Okay. Give us a thumbs up if you're feeling good. Give us a thumbs down if you're feeling a bit confused about what we just did. Just so I can see the chat. Okay. So a lot of today will be going between the rules for exponents, the notation, going to write it up the long way, writing it up the short way, and just switching between the different ways. So lesson body. Okay. Let's go to these first two. I want you to write A and B in exponential notation, and then I want you to put that in the chat. And I'll make it nice and big so you can see. And if we like, we can even count these. 1, 2, 3. And then, Lebo, is there anything in the chat that I should be aware of, or anything important, or everything seems to be going okay so far?
I think so far everything's going okay.
Okay, perfect. Okay, so I think everybody's seen this. We've multiplied by 7 11 times. And so instead of writing this whole long thing, we can simply write 7 to the power of 11.
Sorry, Mr. S, there's a question here in the chat from Kanya to please explain. So I'm not really sure what Kanya is referring to. Kanya, could you please be specific? Okay. We seem to have lost Mr. S. Mr. S, are you still there?
Oh, hi. Oh, I think he's back now. Sure.
Okay.
That was a close. Hello.
I'm back. I'm going to switch to mobile data because I think obviously there's something going on with my data, so or my Wi-Fi. So I'm just going to switch to that. But what we should have seen is we have 1, 2, 3, 4, 5 repetitions. And so what we can say is that it's that thing to the power of 5. But now we actually go one step further than that, guys, because 2 times 3 can actually be written as 6. And so we write it as 6 to the power of 5 like that. So because basically we want to simplify that as much as we can. And so that's how we would do it. Okay, let's have another go at this. Oh, where does the 6 come from? So Tukela, what is 2 times 3 the same as? Ooh. 2 times 3 is the same as 6. And so we can simplify that further. Leslie, I see you have your hand is up. Do you want to unmute yourself and ask a question? Leslie? Do you want to unmute yourself, or is that a hand up by a mistake? Okay, I'm going to assume it's a mistake. Let us do this next set of questions. So what you'll notice now is that we have 4 questions. And while you do those questions, I'm going to take questions from the floor. And you have to simplify these basically for me. And I want you to learn I want you to use the properties of exponents as you do this. Okay. Are there any questions, Lebo, that okay, I don't think there is. So
no, not so far.
And can you see the screen nice and clearly?
Yes, it's very clear. We have a question from Pumelela.
Okay, go ahead, Pumelela.
What do the dots mean?
So the dots are another way of writing multiplication. So they're the same thing.
Oh.
Yeah.
Okay, so thank you.
Pleasure. Okay, and once you've got an answer for number 1 or number 2, put it in the chat and let's see what you have. And again, I'm not really too worried if you get this wrong or right. I want you to commit to an answer, because then when I go through the answer with you, you'll remember that answer better. Okay.
Mr. S, are you available to take 2 questions?
Okay, who is asking a question?
Kanya.
Go ahead.
Oh, ma'am, I just wanted to ask, what does the dot mean?
Okay, so as Mr. S explained before, the dot is just another way to write multiplication.
Yeah. So
Yes.
okay, let me. So for the very first one, because we've got 4 times 4 times 4 times 4, that should be 4 to the power of 4. Now, normally a big number like that we would just leave it like that. If you want to write it, you could. It's the same as 16 times 16, which is 256. But normally we would just leave it in the 4 to the 4, you know, thing, because that's considered simplified. So think about how you can use that to help you in the second one. Now, I'll give you one little hint. If there's no power written, it means that it's actually to the power of 1.
1.
Yeah.
So it's 4.
So what is the answer for number 2 going to be?
34.
Remember, with exponential notation, we always ask ourselves what's being multiplied and how many times is it being multiplied? Yes, Timbesile. Yes. So if we wrote this out the long way, this would just mean like that. Or we can start to notice a bit of a pattern that whenever the bases are the same, we can add the powers.
4.
Now, 4 times 4 times 4, actually, if you multiply it the long way, it's not 32, it's actually 64.
4, 8,
Okay.
3.
So see if I can help you for number 3 and 4. And if I could ask you to please leave your, unless you're asking a question, to leave your microphones on mute, please. So I think some people are not on mute. If I could just ask you to please stay on that. Myself, that's perfect. Okay, thank you, Level. Okay, so what is the answer for 3? So the answer for 3, again, I'm writing this out the long way so we understand it, but you may notice a bit of a pattern here. And I'm using dots for multiplication. And what you see here in the end, it's just going to be 3 to the 4, which if you kind of do it the long way, it's the same as 9 times 9, or it's the same as 81. These are all equivalent. But something I want to spot is, it seems like whenever the bases are the same and we're multiplying, we simply can just add the 2 powers together. And think about why that makes sense. Okay. Now let's have a look at number 4. I'm going to wait some more time for some more answers to come in on number 4. There's a question, I think. If we could unmute Tikamor Cuevo, I think. Tukela says, I know the dots are times, but they're confusing. I get you, Tukela. The problem is we use dots a lot because they take up less space than the big X looking sign. So I think we kind of just have to get used to it. So for question 4, a couple of answers are coming in. I want to point out that there's actually a power that's hiding in question 4. What is the power, when there's no power written, what is the power that's hiding over here?
1.
It's 1, yes.
1.
Okay, you're in the house. There we go. All right. So now, if we know that, if we wrote this out the long way, we would really just get that. Just 2 to the 5. Lebo, do you want to allocate some more questions?
Yes, we have one from Tikom Cuevo. Tikom Cuevo, can you ask your question?
Yeah.
Oh, he lowered his hand now, so I guess we can answer Untatile's question. Untatile?
Yes. Go ahead. Okay, I'll take a few more questions. Okay, go ahead. Yeah.
Can you please just restart, because I just entered now? Can you please just show me?
Okay, which question are you talking about?
Question 2.
So question 2 is the 4 to the 1 times 4 squared.
Yes, okay.
So all that we're doing is we're saying, what is 4 to the 1 times 4 squared? And what we did, we said, well, 4 to the 1 is just 4. 4 squared means just 4 times 4. And so in total, the answer must be 4 to the 3. Okay, you'll pick up the same question again in a moment. I'm not going to take any more questions for the moment. I want us to do, let us have a look here. Okay, I'm going to ignore the top line. We're not doing those ones. That's out of question. I want you, ignore that one. I want you to do 6, 7, and, well, let's do 6 and, no, let's do 6, 7, 8. Can you write those numbers in those ones in exponential form? And I want to draw attention to the fact that now we have something called variables. So in this question, we have Q and Q. In this one, we have C, 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 and C. But variables are just numbers which we don't know their names. So how can you translate this from multiplication with the dots to write in exponential form? And I want to see what we can do for 6. Maybe Lebo, what do you think? Should I give them a hint? Should I do number 6 for them? What do you think? Am I being
I think we can give them a hint.
Please don't. Can I quickly try to solve it, sir?
Yeah, yeah. I'll give you,
okay. Yeah.
I'll give you 30 seconds. And then I will do number 6 as an example. But the main goal is I want you to be able to write this repeated multiplication in exponential form. And you're doing 6, 7, and 8. Ah, I see some good answers coming in.
Yeah.
I think you're on the money there. Amakle, I think you're looking good. Okay.
Sir.
Okay. Hand up if you want to ask a question, and then Lebo will allocate you.
Okay, we have a question from Tumelo, Mr. S.
Go ahead, Tumelo.
So may I ask,
Please, go ahead. Yeah.
what happened to the variables you highlighted in green?
I'm going to talk about that in a moment, but the basic idea is variables obey the same rules. So for number 6, you say there is 9, and 9 is multiplied 3 times. So it's 9.
Oh.
And then you could put a dot, or you could say then, how many times is Q multiplied? It's multiplied by itself twice. So we write it as 9 cubed Q squared. What a mouthful. And so that is the correct way of writing number 6. Now for number 6. Yeah. Okay, who else has a question? Okay. Be careful, Charity. You're almost right. There's only one little thing I would be different. I would put a bracket around your minus 26. And I'll explain why in a moment. So for number 7, if you look at this, what is being repeated? Minus 26 is being repeated. And so I'm going to put a bracket around minus 26. And how many times is it being repeated? It's being repeated 3 times. So this will be written minus 26 to the power of 3. So that's a slight difference. I'll give 30 more seconds for number 8. How do we write 8 in exponential notation? Is there a question? Is that
We have a
Tando?
question from Tando.
Go ahead, Tando.
So for question 7, is there a specific reason why we're putting in brackets?
There is, Tando. I'm going to show you why in the next question. But for now, can you just, because I'm almost trying to keep the minus inside the, can I please pause till the next question on that? There is a reason I put it there. The next question will make it clearer.
Okay, sir.
All right. So now, for number 8, you'll see that we have 5c to the power of 4 is one way of writing it. The other thing that's important to start to think about is multiplication has this funny property too. Guys, if some of you could put it on mute, please. A few too many of you are off mute and we're getting some funny sounds. So you could have written it like this, 5c to the power of 4, but multiplication is commutative. So in some ways, we could have rewritten this like this, and it would still be the same thing. And so it's not wrong if you wrote it as 5 to the 4 times c to the 4, that would also be correct. Because multiplication, the order doesn't matter. And so you could have written it in either of these ways. And I know that sounds a bit strange now, but I just want to point that out to you because later on it will make a bit more sense. Give me a feel, like give me a thumbs up if you're feeling okay. Give me a thumbs down if you're feeling very confused. I want to get a feel from the group's feelings at the moment. Have a look at the, okay.
We have quite a few thumbs up.
Okay, I think it's time for a break. So I want you to stand up, get away from your tables. We've been working for about half an hour and we need some air. So I'm going to stop sharing my screen and you're going to see me. And what you're going to do, so you're going to stand up, and we know that our brains need some oxygen. And what I'm going to ask you to do is something called like a midline crossing, I think. Okay, so you take your right hand and you put it on your nose, and then you take your left hand and you put it on your right ear. Okay, but now the tricky bit is that this hand, which is now on your ear, now goes to your nose, and this goes to your opposite ear. Can you do that? And then, can this one migrate back? It's trickier than it looks. So think, this has to go to the nose, it goes to the... And can you get successively faster at this as your brain starts to make the pathways? Notice how your brain starts to figure it out. I'm told by some of my friends that this is a good exercise for crossing your midline, which is an important skill that we all pick up somewhere along the line, but it's okay. And if you practice it lots of times, eventually your brain is so good, you can do it like a dance. Okay, so that was my fun little midline crossing dance. I hope that gave your brain a little break from the mathematics. How did it feel? Did you enjoy that? Who wants to who wants to jump online and tell us how they found that? Was it easy? Was it hard? I'd love to hear some voices. Who wants to tell us?
It was a little bit difficult.
It is a bit difficult. Nebo, how did you find it? It's tricky, huh?
Yeah, quite tricky.
But it's like, it's nice that it's tricky. It forces your brain to zone out.
Yes.
Okay.
At first, it was tricky, then it went easy.
Went easy, yeah. That's a metaphor for learning. It's a metaphor for learning. You just, it's tricky, and then you keep going.
Yeah.
Okay. Guys, we are now going to be presented with these questions. And I want you to notice something. In all of these questions, what we call as the base is the same. So in this question, the base is 6. In this question, the base is the variable y. And what this question is saying is that this thing is being multiplied by this. And what we want to do is we want to write it in exponential form. Now, you may be picking up a little bit of a pattern here that when you have repeated multiplication with the same base, you can actually simply add the powers. So the long way to do it would be to say, well, 6 squared is 6 times 6, and then 6 to the 5 is just all that. And that's not wrong. You can then see that that's 6 to the 7. But actually, if the bases are the same, one of the rules of exponents is you can add the powers. And so how can you use that to help you do 18, 19, and 20? That's what I want to see. And when you've done 18, 19, and 20, pop your answers in the chat, please.
Mr. S, while they do that, we have a question from Amahle.
Amahle, go ahead.
So can you hear me?
I can hear you loud and clear.
For 19, so normally any number to the power of 0, isn't it a 1?
You are spot on. I haven't taught that to you yet. And I need to explain later in a later lesson why that is. But for now, I will give it to you on good faith. 8 to the naught is the same as 1. And so how can you use that to help you figure out your answer? You're quite correct. Well spotted.
Okay,
Mr. Ace, we have another question from Scarlett.
Go ahead, Scarlett.
Hello, everyone.
Hello.
I just wanted to know for number 20, we still need to like add, right? Even though it's integers.
Yeah, so I'm being a bit sneaky in that I haven't explained to you what a negative power is yet. I've kind of just thrown it at you, but I'm wanting you to think like what would be the logical thing to do based on what we've done. And you're quite right. The logical thing based on what you've seen is to add the two powers together. Okay.
Okay, cool. Thank you.
Okay. Any other questions? Okay. So I think most of you in the chat, I can see that this, even though it's a variable, because it's the same, this is going to be y to the power of 20. Now, 19, the sneaky bit, well, there's actually two ways of doing this. The one is to say, well, what's 1 plus 0? It's just 1. And so it's 8 to the power of 1. Or some of you may say, well, I can ignore this because it's 1, in which case you get 8 to the 1. Same answer. You still get 8 as your final answer. And then for 20, what you're going to do is you're going to add the powers. Oh, I made a mistake there. Sorry. You're going to say 4 plus minus 3, which really just gives you a to the 1 or just plain old a. Another thing with exponents is when there's a 1 there, we don't write it. It's kind of like, I call it the phantom 1. It's there, but we don't really need to kind of think about it too much. Kanya, I see your hand is up. What's your question? Yeah.
So why did you put the brackets on 4 plus brackets minus 3?
Oh, I don't have to do that, but I was trying to emphasize the fact that I'm adding the two powers, but it wouldn't have been wrong to say 4 minus 3, but I was just emphasizing that we add the powers. Yeah. Okay, let's see. All right, now we are going to do these 4 questions. Now, I'm going to, what should I do? I'm going to ignore this one for now. I need to talk to you a little bit more about other stuff first. But you can do A, B, C, and D. And they're getting a little bit trickier now. And remember, when you put the answers in the chat, if you want to put a power, you just put a little upside down triangle like that. So over to you guys. I want you to try and do this almost independently. I will take questions as we go, but I'm not going to steal your thunder on this one. You are going to shine brightly by yourself, and then I will give you feedback in a little bit of time. Klono, you're almost right. You just left out a little important notation. So it's not 2xy. It's close, but not the same. What do you need to do to modify your answer to make it read correctly? So the answer here is not 2xy. It's something else. So if you look at this question, the bases are the same. They're 2. And so you know my final answer is going to be repeating. How many times did I repeat 2? What do I need to do with this x and y? What have I done in the previous exercises? So for example, if we had 2 squared times 2 to the power of 3, I wouldn't get 2 to the 6, would I? what would I get? I'd get something else. How can I use that to help me?
You'd say, I'm not sure, but no, so on that one, just rub.
What do we normally do? If we have, think about this. If we have 2 to the 2 times 2 to the 3, wouldn't it just be that?
No.
Getting a bit harder now.
No.
No,
No,
Mr. S, Pinky actually
Oh,
got
wait.
it in the chat there.
Or did she?
Yeah.
Well done.
Yes, but sir, I think, sir,
So isn't the answer here, whenever the bases are the same, hadn't we picked up that we simply add the powers together? And so the answer should just be x plus y. So if the bases are the same, we add the powers. Now, this is different to something like this. Okay, so that's why I'm starting to mix them together a little bit here to kind of show you the difference. That is a hard one. Yeah, but let's just go back for a second. Let's look at here. What happened with this one over here? When we had 10 and 10, didn't we add the powers to get 20? When we had 6 to the 2 and 6 to the 5, didn't we get 6 to the 7? We didn't get 6 to the 10, huh? So that's what's important. We're taking that idea, that process, and we're applying it here. Now, what is the answer going to be for B? Yes, shout out to Pinky and Oyama.
Mr. S, we have 2 questions. Are you able to take them?
Yes, I am. Go ahead.
Ayanda?
Hello.
Hello.
So don't we multiply the powers?
Okay, so this is important. There's different situations, and I've really made this in the first one when the bases are the same. Okay, if you notice this, the bases are the same with the 2, you add the powers. So when you're multiplying 2 numbers with the same base, so when we had 6 to the 2 times 6 to the 5, notice how the powers aren't right next to each other. The powers are separate, and we're multiplying 2 things here. In that situation, you add the powers because you're just repeating whatever was there. Now, it's a different situation. Earlier on in the lesson, and I'm going all the way back, so sorry if I'm making you dizzy. Earlier on, it was actually before this. Earlier on in the lesson, we had the situation where we had 2 powers next to each other. Sorry if I'm making you dizzy. When you have 2 powers next to each other like this means you're multiplying because you're repeating what's below. And this is quite a tricky thing to get into your head, but I'd rather slow down and just finish on make sure we get this idea. When 2 powers are next to each other, we can multiply the powers. When we're multiplying and there's 2 bases, but they're the same, you add the powers. Okay. So that is an important idea, and I'm really glad you asked that question. Now, I haven't given the answer for the second one. Wait and see.
So, sir, it's second one, sir. So are you going to multiply the powers?
In the second one, you're going to get x to the 15. And
Yes,
the way
sir.
to see that, and the thing is, I really want you to be able to do it the long way if you have to. Can you see x to the power of 3 to the power of 5? That just means multiply x to the power of 3 5 times. So can you see why it has to be 15? Because of all these 3's over here.
Yes,
Notice
sir.
this. What happens if we look at this answer? Aren't the bases all the same? So if
Yes.
the bases are the same, don't we just add the powers? And that's why we get up to the 15 over here. Okay. But it's a sneaky idea. And I want you to make a very clear difference between when powers are next to each other and when powers are separated like this. Let's try and do C and D.
Mr. S, while they do that, we have a question from Zukanye.
Zukanye, go ahead.
Sir,
Yes.
I wanted to ask if in A, how did we know that the X stands for 2 and the Y stands for 3?
Oh, I didn't. I made that up. So it's a very good question. I was trying to show you what made the question A difficult is it's a variable. So what I did was I made up numbers to show you the idea that I was using. But because X is an unknown, X could have been 7, it could have been 5. I made that up to make it a bit more concrete. But that's a very good question. Thank you. Okay, so it didn't have to be 2 and 3. Yeah. Anybody else? A question? So I want to give you one little hint. I've made these ones tricky because I'm trying to test your understanding. Now, if you go back to the beginning, doesn't 2x to the power of 2 mean 2x times 2x? Because isn't that what exponents mean? It means repeat whatever's below it. So if that's 2x times 2x, what's the final answer going to be?
5x.
Nope.
4x.
Almost, not quite. Okay.
No, 6x.
Okay, slow down for a second. Think about it. Do you agree?
It is x and then the on the top of 5.
Okay. What? Let's go back to
2x to the power of 2.
To the power of 2. Repeat this
X
twice.
to the power.
Okay, guys,
X to the power of 5.
X squared.
Guys, can we just stop for a second? It's a little bit too many voices simultaneously. So I'll take you to another example of this now. We're going to finish the lesson with this idea. 2x times 2x, you multiply two numbers together and you get 4. You multiply x by x and you get x squared. Okay. If you want to imagine multiplying powers, but it gets a bit tricky, it would be 2 multiplied by 1 and 2 multiplied by 1 here, but the answer is going to be 4x squared. I'm going to make up some more questions for you now to explain why this is. But let's first get D. What is D's answer? Okay, so D's answer
X to the power of 5.
Okay, yes, not 6. Because if you wrote it out the long way, you can see there's 5 of them. So it's x to the 5. And if you're thinking about the rule, the bases are the same, so you add the two powers together. So I'm going to make up some of my own questions now to test your understanding of this. I feel like I need to take the same idea and so I'm going to make an E and an F. I want you to simplify. A to the 3 times A to the 4. If everybody could please put themselves on mute. Okay, please put yourself on mute. And then I also want you to work out
Sir?
Sir, I think you're muted.
it's fine. I'm unmuted now. All good.
E is
Everyone?
E is a to the power of 7.
Everybody, let's pause for a second. In my class, I would say hands up or put your hands on your lips. Let's just pause for a second because there's too much joy in the room. We need to focus this energy before it gets out of hand. So I want you to put in the chat and I want to see it. I'm not taking any questions for now. What is your answer for E and what is your answer for F? And then Lebo, if I could ask you just so in the background to start looking for the quiz link to make sure that if we know that it's there or if maybe Nicole, if you're in the background, because we're almost about to finish off now.
7.
Okay, so the answer to E is A to the 7. You're quite correct. Now the answer for F.
Sir, I can't really hear you because the other people is not on mute.
Ah, you like.
Does exponential notation mean? It means repeat something multiplied. So we know.
I don't know.
We get that.
Oh.
Now, if we get that, what's my final answer going to be?
27x squared cubed.
I want to see the answers coming in, guys. In the chat, let's see what we can do. Okay, so 8 to the 7 for E is looking good. F is not 9x cubed. It's almost that. What do we get when we go 3 times 3 times 3? 3 times 3 and x times x times x. What do we get if we do that? Okay.
Mr. S, can you take some questions quickly?
I'm actually not going to take any more questions now because we're almost at the end of the lesson. But the final answer is 27 x cubed. And guys, we're going to stop now because we've done a lot of work. Actually, your brains need a bit of time. I could ask you maybe what you mute everyone for a second if you can, and then I will. It's a bit too much at the moment. Could we? Okay.
I'm sorry, guys. Can you please mute yourself?
Everyone.
Because it shows you.
Okay, can I ask you, Level? Guys, we finished the lesson for the week. If I could ask you please to do the quiz. The quiz is now going to be placed in the actual chat. Is there... Okay, guys, if we could just please... Yeah, thanks. So, Level, do you know if the quiz link is available? Let me see if it's on Slack for live classes. Let's have a look. Oh, here we go. Quiz links. I think it's there. Let's say copy link address. Let's just see, guys. If you could just, there is the link. Oh, sorry, I typed it to the wrong person. So everyone. Why is this? Everyone.
Oh, Nicole just sent it now.
Perfect. Okay. So guys, if you could go off now, please, and do this quiz, and then we will get some feedback about how things are going. Level will stay online to mop up any questions that you may have. But I enjoyed today's lesson. I hope you did enjoy it too. Level, thank you. It was lovely working with you. You were fantastic. So really well done on your first lesson.
Thank you, Mr. Ace. Thanks for having me.